Good morning still. I'm still on photorespiration. I'm re-emphasizing the process, describing the process using a different slide, which is part of the slides that I hope you have received. Is part of all the lecturing slides that you have received. We are starting there where you have got oxygen attaching to RUBP, which will give you 1 phosphoglycolate and 1 phosphoglycerate. Now, photorespiration is about the breaking down further of this phosphoglycolate. Remember, the enzyme that is catalyzing the addition of oxygen to RUBP is the same RUBP carboxylase enzyme, but because it is adding oxygen, it is said to be an oxygenase enzyme. So it can be a carboxylase when it is adding carbon, and it can be an oxygenase when it is adding oxygen. The next step, this phosphoglycolate is one of the products that are formed together with phosphoglycerate, PGA, which is not shown here, but that is not our focus. That phosphoglycolate is going to lose its phosphate group and becomes a glycolate there. All this is happening within the chloroplast in the leaf of a plant. The next step is that, and of course, probably the removal of the phosphate group from the glycolate, the phosphoglycolate to become glycolate, there might be an enzyme involved there. When later you get a detailed structure that shows the enzymes involved, probably just check the name of that enzyme there. It's very critical. That glycolate, which is an organic acid, will be delivered from the chloroplast down into the peroxisome. There. The glycolate will be delivered from the chloroplast to the peroxisome. Within the peroxisome, that glycolate is going to interact with oxygen. So it's glycolate plus oxygen, that's the reaction. And the product is going to be glyoxylate, which is an organic acid, and a byproduct, which is hydrogen peroxide. That is taking place within the peroxisome. And there's definitely an enzyme involved in that reaction, the name of which you can Google the process more to get the names of the enzymes there. At least that is basically the exercise I'm giving you. Get the enzymes involved in each and every step in photorespiration. That information you can get through Googling in the internet. That glyoxylate, which is an organic acid, it's going to interact with glutamic acid. Glutamic acid is an amino acid which has got an NH2 group. That glyoxylate does not contain the NH2 group, and therefore it is an organic acid. So when the two interact, the glutamic acid will transfer its amino group or donate its amino group to this organic acid called glyoxylate, thereby aminating the glyoxylate, that is adding an NH2 to glyoxylate, making this glyoxylate from changing to making it to change from being an organic acid to being an amino acid called glycine, right? This glycine will then be transported into the mitochondrion. It's an enzyme that is involved in transferring the amino group from glutamic acid to glyoxylate, making it to be glycine. Get the name of that enzyme, please. As like in the previous slide that deals with the description of the process, the two glycine molecules, the two amino acids, will be delivered into the mitochondrion, which is another organelle involved in the process of photorespiration. Here in the mitochondrion, the two glycine amino acids will interact with each other. That's glycine plus glycine. That's the reaction. And this reaction will yield an amino acid called serine. And as part of the byproducts that are released, carbon dioxide is part of that byproduct. Ammonia is also part of that byproduct. And there are enzymes, at least enzymes, involved in this reaction in which two glycine molecules are interacting, resulting in the formation of one amino acid called serine, with carbon dioxide being released as a byproduct and ammonia also released as a byproduct. You will see serine will be delivered back into the peroxisome, and it will further be broken down, be transformed within the peroxisome until glycerate is formed there. That glycerate will be delivered into the chloroplast. Inside the chloroplast, that glycerate will be phosphorylated to form phosphoglycerate. This phosphoglycerate is a PGA. At least if you get two of them, or at least one of them, this PGA will then be delivered into the Calvin cycle, and it can be used to form the glucose. So that is basically the process of photorespiration. Please, step by step, each and every step from the initial step of oxygen combining with RBP, find the name of, for the first step at least I've already told you that's RBP, oxygenase enzyme. Then you are getting phosphoglycolate being formed. It releases a phosphate group to become glycolate. There is probably an enzyme involved there. Get the name of that enzyme. Then you get glycolate being delivered to the peroxisome. Inside there, glycolate interacts with oxygen. That interaction yields glyoxylate and hydrogen peroxide as a byproduct. There is an enzyme involved in that step. Get the name of that enzyme. The next step is glyoxylate interacting with glutamic acid. That will yield an amino acid called glycine and an organic acid called ketoglutarate. There is an enzyme involved there in that step. Get the name of that enzyme. Lastly, this glycine is delivered into the mitochondrion, and another glycine delivered into the mitochondrion. Two of those glycine molecules will interact with each other, and that interaction is going to yield one amino acid called serine. It is going to yield carbon dioxide as a byproduct and ammonia as a byproduct. There are two enzymes involved here in this last step. In this step in the mitochondrion, it's not necessarily the last step, but it's the most critical step, because it is the step that sees the whole process releasing carbon dioxide. We started with oxygen being combined with RBP, but in the mitochondrion, we can see the carbon dioxide being released as a byproduct, like I've explained in the other slide. That is why this process is called photorespiration, respiration that takes in the presence of light. In respiration, you get the consumption of oxygen. and you get the release of carbon dioxide. That is exactly what is happening here. But respiration and photorespiration are not one and the same processes. They just involved the consumption of oxygen and the release of carbon dioxide, but they are not one and the same processes. And please find time to search for the differences between photorespiration and respiration. That is very critical. That's an exercise that I'm giving you. Get the difference between photorespiration and respiration. It must be easy for you to search and find that on your own. I thought I should repeat the description of this photorespiration process so that you understand it. I think I've talked about photorespiration 3 clips already. The reason is because this process is very, very important. When it happens, it limits photosynthesis, and it is basically a very satanic process in plants. You will see how some plants have developed mechanisms to minimize this process and therefore be able to push up productivity. Thank you. I hope you enjoyed this lecture. Bye.